Now I want to talk about a couple more diode applications. So this is just going to be kind of a short list. So one thing we can do with diodes is make clippers. So this is a device that clips an input signal. So if you have a signal that's varying in time, you can kind of chop off the top or the bottom. So that might look something like this. So we have an input voltage that goes to, we'll say we have a diode and a battery in series here that's connected to ground. And then here we have another diode and battery in series that's connected to ground. So note that these diodes are put in opposite directions, and this voltage source is backwards from this voltage source. So this is plus and minus, this is minus and plus. So if this is ground and this goes like this point is at a voltage below 0. This point is at a voltage above 0. So I should label these. We'll call these voltages E2 and E1. Since these are voltage supplies, we will use E. So if I send in a voltage signal that is a sine wave or anything that's varying in time, our output here is going to be clipped by these diodes, and the output I'll draw down here. It is going to look like this. This is like for a single oscillation. It might look something like this, where this value is E1 and this value is E2, and we're ignoring the diode drops. We're assuming these are ideal diodes for this purpose. So you can see by adjusting E1 and E2, you can adjust where you are cutting off the signal, or even if you make these voltages 0, you could cut off the whole top half of this. And of course, if E2 is equal to 0, if this is a diode connected to ground, that is exactly our half-wave rectifier. So we've already seen something that does something like this in one extreme case. So these are very useful if you want to limit the voltage going into a circuit, if you want to prevent damaging the circuit. For example, you can put in clippers that protect everything downstream. All right. The next one I will mention is clampers. So voltage clampers, I'm not going to draw any examples of, but the idea is if you have an AC signal, you can shift that AC signal to a different average voltage. And it does this by means of diodes and capacitors. If you're interested in this, I encourage you to look it up, but I'm not going to ask too many questions about voltage clampers. I just wanted to get that out there. Okay, lastly, there's one other cool clipper that I wanted to mention, and this is a Zener clipper. And here we have our input voltage and our output voltage. And going to ground, we have 2 diodes, actually, and they're connected like this. So we have 2 diodes that are Zener diodes, and they are pointing face to face here. So what this is going to do is if Vn is really, really big, for example, then one of these diodes is going to conduct in the forward direction, which gives us a 0.7 volt drop, and the other one's going to conduct in the reverse direction, which gives us a Zener voltage drop. And so this is going to force the output voltage to be no more than a Zener voltage plus a 0.7 volt diode drop from 0. So this is going to limit the output to plus or minus V Zener plus V diode R, presumably 0.7 volt drop. So this is again very useful for protecting circuits downstream. This is a pretty cheap way of ensuring that voltages that are too big don't make it to sensitive components downstream in the circuit.